In question number 26, it says that a clock with a metallic pendulum is 4 seconds fast each day at a temperature of 20 degrees centigrade. The coefficient of linear expansion of given metal is. So since the clock is fast, right? So we can say that when we increase the temperature, the time period increases, so the clock becomes slow. And if they decrease the temperature, then clock will become fast, right? Time period will increase and the clock will become fast. So that means this temperature is lower than the actual temperature, right? Yes. And we know that the time lost by the watch or pendulum per second will be given by, the time lost per second will be given by half alpha delta theta, where delta theta is the change in temperature, right? This is the time lost per second or gained per second by a pendulum clock, right? So but it says that for each day it gains 4 seconds. So that means for one day we can write the total time gain will be how much? Total time gain will be delta t by t into 86400, because number of second in one day is 3600 into 24, that will give you 86400 seconds. That is the total number of second in one day, and this is per second, right? This is our per second time gained or lost per second, right? But according to the question, this is equal to 4 seconds. So if I put the value of delta t by t, that means half alpha delta theta. So let's say our final temperature is theta and initially 20 degrees centigrade. So we can write theta minus 20, because we know that the clock is moving faster. So the temperature, the 20 degrees centigrade must be lower than its actual temperature, right? So theta minus 20. That will be equal to 4 by 86,400. So theta minus 20 will be equal to 4 by 86,400 into 2 by alpha. And what is the alpha? Alpha is given 2.77 into 10 to the power minus 5. So this is our alpha, right? So if I calculate this, we will get 3.34 degree centigrade. So this is our calculation. So we can say that our actual temperature at which it will give the correct reading will be equal to 20 plus 3.34 degrees centigrade, and that will be equal to 23.34 degrees centigrade, right? So this is our answer. But according to the question, we need approximate value. If you check the option, we can see that 23 degrees centigrade is the closest value. So we can say that our option number 1 will be the correct choice. Now let's move to the question number 27. In question number 27, it says that choose the correct statement among the following. We have to choose the correct statement. So first statement says that the boiling point of a liquid is independent of superincumbent pressure. Superincumbent pressure is the pressure from above. So whatever pressure you will apply on the liquid from above is called superincumbent pressure. So we know that if you apply the pressure on a liquid, then its melting point and boiling point will change. So first statement says that the boiling point of a liquid is independent. No, this is false. The melting point of liquid is independent. Again, this is also false. At the pressure below that of its triple point, no substance can exist as a liquid. Yes, this is the true statement, because below the triple point, the water cannot exist or liquid cannot exist. It will be converted into ice or solid form. So this is the correct statement. So we can say that our option number 3 will be the correct choice. Now let's move to the question number 28. In question number 28, it says that a wall has two layers X and Y, each made of different material. Both layers have same thickness. The thermal conductivity of X is twice that of Y. At steady state, the temperature difference of opposite faces of wall is 54 degrees centigrade. The temperature difference across Y layer is. So we have to find the temperature difference across Y. So let's say there is a two-layered wall like this. According to the question, both layer have the same thickness. So let's say this has a length L, so this will also be a length L, right? And the thermal conductivity of X is twice that of Y. So let's say if this one has thermal conductivity K, so this will have 2K, right? And question says that at steady state, the temperature difference of opposite faces of wall is 54 degrees centigrade. Let's say here the temperature is T1 and here the temperature is T2. So according to the question, T1 minus T2 is equal to 54 degrees centigrade, right? So we have to find the temperature difference across Y layer. So if this junction has a temperature T, so we have to calculate T minus T2. We have to calculate this T minus T2, right? So we know that heat flow rate in steady state will remain same through both layer, right? So if Q amount of heat enters through this layer, so from this layer also the Q amount of heat will exit. So according to the formula of heat flow through conduction, we can say that heat flow rate through layer X will be equal to heat flow rate through layer Y. And what is the formula of heat flow rate? We know that the formula of the heat flow rate is Ka delta T upon L, where A is the area, K is the conductivity, delta T is the temperature difference, and L is the thickness or length. So according to the question, the X has thermal conductivity 2K. Both will have the same area. So A delta T will be T1 minus T divided by the thickness, that is length L. That will be equal to the conductivity K, area A, and the temperature difference will be T minus T2 and the length is L. So this will be our heat flow rate from both the, and they should be equal. So as you can see that Ka by L will cancel out. So we can write 2T1 minus 2T will be equal to T minus T2. So we can write 2T1 plus T2 will be equal to 3T, right? But according to the question, T1 minus T2 is equal to 54 degrees centigrade. So we can write T1 will be equal to 54 plus T2. So if I put the value of T1 here, so we can write 2 into 54 plus T2 plus T2 will be equal to 3T. What we have to calculate? We have to calculate T minus T2. So we can write it 2 into 54 plus 3T2 will be equal to 3T. So we can say that T minus T2 will be equal to 2 into 54 divided by 3, and that will be equal to 36 degree centigrade. So we can say that our option number 4 will be the correct choice. Now let's move to the question number 29. In question number 29, it says that the temperature of a body falls from 70 degrees centigrade to 60 degrees centigrade in 6 minutes, obeying Newton's law of cooling. This is the approximate formula for the Newton's law of cooling. So according to the question, it says that 70 to 60 in 6 minutes. So we can write 60 minus 70 upon 6 will be equal to minus K 60 plus 70 divided by 2. And in the question, surrounding temperature is 30 degrees centigrade is given. So minus 30, right? So when you will solve it, you will get the value of K as 10 by 6 into 35. This will be the value of K when you will solve it, right? Now again the question says that the time after which the temperature of body becomes 45 degrees centigrade from 60. So again the body cools from 60 to 45. So again if I use this formula, so we can write final temperature is 45, initial temperature is 60, and we have to calculate the time. So we don't know the time. So if I use this same formula, minus K into 45 plus 60 by 2 minus 30, right? So if I solve it, if I put the value of K, so we can write minus 15 by T will be equal to minus 10 by 6 into 35, if I use the value of k from above, we will get 45 by 2. So by this we can say that t will be equal to, minus minus will cancel out. So we can write t will be equal to 15 into 6 into 35 into 2 divided by 10 into 45. So this will be 3. 15 3s are 45. 3 into 2s are 6. 2 5s are 10. 5 7s are 35. So you will get 14 minutes. So our option number 4 will be the correct choice. Now let's move to the question number 30. In question number 30, it says that a body emits maximum spectral emissive power at wavelength 5200 angstrom, and the same body at some other temperature emits maximum spectral emissive power at wavelength 4800 angstrom. That means body is same but the temperature is different. So we know that from the Wien's displacement law, the wavelength of the maximum spectral emissive power into the temperature will remain constant. This is called Wien's displacement law. So if the wavelength is lambda 1 and temperature is T1, and finally the wavelength is lambda 2 and temperature is T2, so lambda 1 T1 will be equal to lambda 2 T2. So we can say that the T1 by T2 will be equal to lambda 2 by lambda 1. But according to the question, lambda 2 is 4800 angstrom and lambda 1 is 5200 angstrom. So 0 0 will cancel out, and we know that 12 4s are 48 and 13 4s are 52. So the ratio will be 12 by 13. So we can say that our ratio will be 12 by 13. So option number 1 will be the correct choice. Now let's move to the question number 31.